Welcome to the video on deductive proofs. First, we're going to talk about equality versus identity. Equality, which is the two lines here, is when two things are equal, and it typically only works for certain numbers. So here we have y equals 3y plus 9. We'll solve for y by subtracting 3y from each side. So we get negative 2y equals 9, and when we divide both sides by negative 2, we get that y equals negative 9/2. So this equation is only true if y equals negative 9/2. Next we have identity, which is 3 lines, and no matter what number is plugged in, the equation is true. So here for our example, we have a plus b squared is the same as a squared plus 2ab plus b squared. We can manipulate the left side of this equation to see how it's the same as the right side. So we have a plus b times a plus b. And when you distribute that, you get a squared plus ab plus ab plus b squared. And when you combine your like terms, these ones right here, you get a squared plus 2ab plus b squared. So you can see this is the same as the right side of the equation. So no matter what you put in for a or b, the statement will still be true. Next, we'll talk about proofs. So there are left-hand side to right-hand side proofs, LHS to RHS proofs. Here's an example of one. It says, show that 1/5 plus 1/20 equals 1/4. Show that the algebraic generalization of this is 1 over m plus 1 plus 1 over m squared plus m is the same as 1 over m. We'll start by setting up our left-hand side to right-hand side proof. We'll write LHS for our left-hand side, a bar in the middle, and RHS for our right-hand side. We have 1/5 plus 1/20, and it equals 1/4 on the right-hand side. So with these proofs, you can't subtract or add things from side to side because we need to manipulate just one side to show that it equals the other side. So you can't cross this bar when you're solving these equations. Typically, it's best to start with whichever side is more complicated because it's easier to simplify something than to try and make something more complex. So with this problem, we'll start on our left-hand side and simplify it. We'll need to find a common denominator, which is 20, so we'll multiply our first fraction by 4 over 4. So we'll get 4 over 20 plus 1 over 20, and when we add that, we get 5 over 20, and if we divide the top and bottom by 5, then we get 1/4, which is the same as our right-hand side, so we'll write left-hand side equals right-hand side. We'll do the same thing with our algebraic generalization. We'll write our left-hand side and separate it from our right-hand side. So we'll have 1 over m plus 1 plus 1 over m squared plus m equals 1 over m. We're going to solve our left-hand side because that's the one that we're going to be able to simplify. So we'll factor out m from our second fraction. So our denominator will become m times m plus 1. So to get a common denominator, we'll multiply our first fraction by m over m. So then we have m over m times m plus 1 plus 1 over m times m plus 1. We'll combine these fractions to get m plus 1 over m times m plus 1. And then we can divide the top and bottom by m plus 1 to get 1 over m, which is the same as our right-hand side. So we've proved that our left-hand side is equal to our right-hand side. Here we have another example that says, show that x plus 5 squared minus 3 is the same as x squared plus 10x plus 22. So we'll set it up, our left-hand side and our right-hand side. We have x plus 5 squared minus 3 is equal to x squared plus 10x plus 22. So we'll go ahead and solve our left-hand side by multiplying x plus 5 times x plus 5 and then subtracting 3. So we're going to distribute and get x squared plus 5x plus 5x plus 25 minus 3. And then we'll combine our like terms to get x squared plus 10x plus 22. And that's the same as our right-hand side, so we've proved that our left-hand side is equal to our right-hand side. With this one, we could also try solving the right-hand side to make it equal to the left-hand side. So if we set that up, we have left-hand side, right-hand side, x plus 5 squared minus 3, x squared plus 10x plus 22. So our left-hand side is in vertex form, so we'll try to switch our right-hand side to be in vertex form. So we'll have x plus half of our b value. So 10 divided by 2 is 5. So we'll have x plus 5 squared plus 22. When we turned our x squared plus 10x into our x plus 5 squared, we added 5 squared. So we need to subtract 5 squared at the end. So minus 25. So this will become x plus 5 squared minus 3, which is the same as our left-hand side. So we've proved that the left-hand side is equal to the right-hand side. In summary, equality is when two things are equal, but it typically only works for certain numbers. It doesn't work all the time for every number. An identity, on the other hand, works no matter what number is being plugged in. So no matter what number you put in, the equation will still be true. And when we're solving proofs, we've learned that we need to choose a side to solve and manipulate the numbers or variables on that one side until it becomes equal to the other side. And then you've proved that the two sides are equivalent. That's all for this. Thanks for watching.